lesson, let's talk about the analysis of comparative science. So the foundations of comparative forensic science. So it is pattern-based evidence. And what that means is that you're examining the evidence based on patterns which require critical thinking and an understanding of various factors. So what does that look like? You've got your objectivity versus your subjectivity. You've got 3 different types of logic. You've got your form, your pattern, and you've got feature persistence. You also have natural and unnatural patterns. You deal with expert judgment and levels of detail in images. So objectivity versus subjectivity. Okay. What does that look like? What does that mean? What is one versus the other? So your objectivity refers to judgments based on observable, measurable facts, something you can see and actually measure. In one of our required articles, Monson and his associates from 2019, they mentioned that objectivity ensures that forensic analysis is grounded in evidence rather than personal biases. So you don't have to worry about if someone's opinion or judgment is in play in here. It's the facts and only the facts. And there's really nothing to argue with that because it's straight evidence and factual information. Your subjectivity, on the other hand, is the opposite. It involves your personal biases and interpretations, what you think about something. In that same article, they also say that subjectivity can introduce bias, potentially affecting the reliability of forensic conclusions. Now, how does that impact the judgment? Well, your objectivity leads to more reliable conclusions, while your subjectivity can skew your results. If you're basing everything on subjectivity, then you deal with, is it actually right or is it not? That's where the phrase, it's subjective, kind of comes from. Whereas your objectivity is something you can rely on for sure because it's based on the facts and only the facts. And it has nothing to do with how you feel about the situation. So let's look at the impact of objectivity and subjectivity. So an example of objectivity would be the procedures in fingerprint analysis, your standardized procedures. They're straight, laid out, black and white. Whereas an example of subjectivity would be variability in interpreting forensic evidence. So due to personal experience or opinion, this is actually seen in our textbook where they mention this. Basically, your subjectivity is if you're analyzing something and it's based on your interpretation of the evidence. If you're looking at a specific shade of a color and in your mind it is a light blue and someone else says, oh, well, it's a medium blue, that's based on your view on it. Whereas if you're looking at the standard procedures in fingerprint analysis, it is cut and dry on how you analyze a fingerprint, and there's no two ways about it. Types of logic in comparative forensic science, there are 3 different types that experts can use when comparing this evidence. And those 3 types are deductive, inductive, and abductive logic. So what is it? What does it look like? Your deductive logic is drawing specific conclusions from general premises. According to our textbook, Vanderkolk in 2009, they mention that deductive reasoning allows forensic experts to make definitive conclusions based on established facts. So this is the fact, and you can deduce this. Your inductive is actually inferring general principles from specific observations. Vanderkolk mentions that inductive logic helps forming hypotheses about evidence based on observed patterns. You can infer, you can induce based on patterns that have been observed or specific observations. And lastly, abductive is reasoning to the most likely explanation. According to our textbook, he mentions abductive reasoning is crucial for developing plausible explanations from incomplete evidence. So if you have some evidence but it's not quite there, it stands to reason this is the case, or most likely this is what happened. It doesn't mean definitive. That would be your deductive. It's not definitive on that. It's basically kind of like a hypothetical. Let's look at a case study example. Let's use fingerprint analysis. So remember, your deductive is going to be general principles that lead to a specific conclusion. So suppose a fingerprint at a crime scene matches the known pattern of a suspect's fingerprint in a database. Okay, so in this example from Hong, Nguyen, and Nguyen in 2016 in an article about fingerprint comparison, it shows two different fingerprints and they're comparing one to the other, and in this case fingerprint matching based on minutia. So this is definitive based on facts. Now your inductive is going to be your specific observations that lead to general conclusions. So based on several cases where fingerprints from similar types of crimes have led to certain types of suspects or patterns, forensic analysts might hypothesize that a fingerprint from a new case could belong to someone with a similar profile. Now, this is used if you're dealing with like a serial killer or crimes that have happened in different states, but it kind of follows a similar pattern. So and this is from Meta in 2017. And this is just from an article that shows how fingerprints and blood type could possibly be related. And in this case, it's just showing the distribution of fingerprint patterns with blood groups. So sometimes your inductive logic can also be used to relate characteristics or patterns with certain races or a class of people. And then your last one is your abductive logic. So remember, this is inferring the most likely explanation from incomplete evidence. So it's basically inconclusive, or there's little there. So if a partial fingerprint is found at a crime scene and there are several suspects, the analyst might consider that the most likely suspect is the one with a fingerprint that matches the partial print, given the context of the crime and other evidence. So in this case, here is an example of a partial fingerprint. It's one of those that you can't definitively say it is this person based on a partial. You're kind of guessing, but you're going to need more evidence to officially say this is a match. This is it. Feature persistence. What is that? What does that look like? So form is the shape and the structure of evidence. So like your tool mark. So if you think about the form of something, the shape of something, what something looks like, it's pretty basic on that. When you're talking about the form of evidence, you're talking about what it looks like. Whereas the pattern of it, what pattern does it leave? Does it have a pattern? If it's a tool mark, what kind of pattern does that tool mark leave? So it's going to be your repeating features that help in identification. We're used to grade school when they tell us about patterns. If I have a pattern, I have red, blue, what comes next? That's essentially what a pattern is. And then you've got feature persistence. This is a little bit different. All three of these contribute to unique characteristics, but feature persistence is going to be the durability of those features over time. So if there is a certain shape or a structure or a print or a tool mark that's left behind, what does that look like, hours from now, days from now, weeks from now? Is that very durable? Does it hold up? Sometimes if you find evidence, maybe it looks like it's been worn away, and its feature persistence just isn't really there. It doesn't have a strong feature persistence. It's not very durable. So maybe it fades over time. So one of our articles, or required articles from Monsoon and his associates, was feature persistence is key to establishing uniqueness in forensic evidence. So everything has a form. Everything mostly may have a pattern, but the feature persistence is pretty much that identifying marker right there. And what this article mentions is that establishes its uniqueness. And that's kind of what helps in kind of narrowing down where we're going on this. So what about natural versus unnatural patterns? So this is kind of distinguishing the similarities and differences between what a natural pattern is and a non-natural pattern and those repeatable patterns. So we talked about a pattern is something that's going to repeat over and over. So red, blue, red, blue. Okay. So natural patterns usually occur naturally. Your fingerprints, they're going to have patterns to them. Okay. Your whorls, your loops, okay, they look kind of like a pattern. Your fingerprints are natural. It's not something that you make your own fingerprints. You're born with them. Whereas an unnatural pattern is pretty much the opposite. It's not something that happens naturally. It's created. And it sounds kind of weird to say it's unnatural, but it's created. So something unnatural, I think of it in a way of it doesn't happen in nature, right? So a pattern on a butterfly happens in nature. But if I take a tool and I repeatedly carve into wood, okay, I can make an unnatural pattern, right? So your wear marks on a tool, on your shoes, on stuff like that, that is a repetitive process, but it helps distinguish something natural from something unnatural. Is this something that happened in nature or by itself, or is this something that someone made? Now, in this same article from Monson and Associates, there's an understanding natural and unnatural patterns, and it's essential for accurate forensic analysis. And that does help narrow down if something happened. Did it happen naturally or did it happen unnaturally? And then that can help narrow it down to less of what that object could be. And this is an image that I got from the Minnesota Department of Public Safety. It was not dated. I did access it this year. So, and this is a website that's constantly updated, but this is showing a tool mark, looks like a flathead, making a scrape mark. So this is obviously not natural. So if I were to encounter this, I could say, oh, more than likely someone did this. Whereas if there's a mark in the sand, it's one of those that it could have been made naturally by like a pebble rolling, or it could have been made unnaturally by someone making that mark, right? So expert judgment and source determination. How does an expert's judgment be used to support the belief that two marks originated from the same source? So two marks can look like the same, right? And they can look like they came from the same source, but did they? And so the role of an expert judge, or the expert judgment, or the judgment of an expert, however you want to put it, is that this is how the expert assesses whether two marks originated from the same source. It's not asking your neighbor, hey, do these two look the same? Because for just anybody, for a normal person, they may look the same. This is going to be someone who is an expert in this field, who has experience in all of this. And from our textbook, expert judgment is critical in linking evidence to a specific source. So if I'm wanting to know, hey, where did this tool mark come from? I'm going to want to match it to its original source. I'm going to want to match it to its tool, whatever made that. This image right here also came from the Minnesota Department of Public Safety. And in here I included a snippet from the article, and it says that similar to bullets and cartridge cases, the examiner will conduct comparative examinations on tool marks using the comparison microscope. So you're able to put one sample under one side, one sample on the other, and you're able to line them up to see if those marks match up. If they match up, more than likely it's going to be from the same source. If they don't match up, it's not the same source. So the tool mark examiner will compare the microscopic features of the test mark and the tool mark on the evidence. And then it goes on to say, if the marks match, the examiner can determine that the tool used to create the test tool mark also made the mark on the evidence item. And this is where the expert judgment is going to come into play and figure out that source determination, if this is a match or not. All right, so what about details of the image? So we can match something up, but that doesn't always mean that we're just looking at two things. side by side. It might mean that we actually have to look at it in more detail. Maybe we don't need as much detail. And what that is called is your macro versus micro detail. So your macro, if you think of something that's macroscopic, or if you've ever heard someone say, look at the big picture, that is your macro detail. It's a broad view of the evidence, something you can just see with your naked eye. So one of the Creative Commons photos I found online was just someone taking a picture of a window. Just something you can see with your eye. Whereas your micro detail, if you think of microscopes and microscopic, it's the little tiny details that it's like a piece to that puzzle. You're zooming in to find more than what meets the eye. So these are going to be your fine details that are visible under magnification. Another Creative Commons photo I found was this image under a microscope. So something like this, detail like this, is not something you're going to be able to see with the eye. You're going to have to look under magnification. Now, this article from Monsoon, it's a great article, and they go in to say that different levels of detail provide varying insights into the evidence, from overall patterns to minutia features. And so that level of detail can also help when you're trying to compare samples. All right, so let's recap objectivity, subjectivity, your logic types, and your pattern analysis, and your expert judgment. So I created this nice, fancy, but complex flow chart to go into everything that we've talked about. So you've got your comparative science, and what makes up that comparative science is your objectivity, your subjectivity, your three different logic types, your expert judgment, and your pattern analysis. So more specifically on your objectivity and your subjectivity, influence on judgment, right? If you're looking at something objectively or subjectively, right? So now I drew an arrow that plays a role in your expert judgment. Now, looking at your logic types, you've got your deductive, abductive, inductive. Your logic types are also going to play a role in your expert judgment. What type of logic is that? Is it something that it's definitely there? Is it something that you're comparing one case to a different case, or are you trying to infer? And then your pattern analysis, you've got your form, your pattern, and your feature persistence. This is also going to play a role in your expert judgment, okay? Because you're dealing with comparing, for example, tool marks, what something looks like, how that feature persistence holds up over time. So all three of these are going to tie back into your expert judgment, and they're all going to relate to your expert judgment. They don't necessarily relate to each other or affect each other per se, but they do relate to that expert judgment in your source conclusion and your combining evidence and reasoning. So that expert judgment is really the key there on where everything else falls. So however everything else falls is going to affect your judgment. And the whole overall goal is to be as objective and less subjective and less biased as possible when examining the evidence. Can we be 100% objective? Absolutely not. Is that the goal? Absolutely. So thank you for joining me today on Forensic Comparative Sciences, and I hope that this made a little bit more sense. References that I've used, with the first three being from the Creative Commons straight out of the PowerPoint library, and the rest have just been fantastic articles that help tie in these great topics to what I have talked about today.